As with the inverse sine function, the cosine function does not have an inverse because it doesn't pass a horizontal line test. So what we need to do, again, is restrict its function, restrict its domain, so that we can look at just a section of the cosine function and then look at some ideas about its inverse. So we're going to restrict it then from 0 to pi. So within that restriction, we can look at this cosine function from 0 to pi and look at its domain, or look at its inverse. Likewise, what I drew down here was just that section out of it. This is y equals the cosine of x graph. Its domain is restricted from 0 to pi, and its range within that restriction is from -1 to 1. Its inverse will be all those coordinate points switched around, and we can see then that we have a new domain, which is -1 to 1, which is the range of the cosine function, and its range of the inverse is from 0 to pi, which matches up with the domain of the cosine function. And then you can see that I graphed it here from -1 to 1, and then from a height of pi as it squiggles on down to 0. So because of that, we can look at some inverse cosine types of ideas if we restrict the domain of the cosine function from 0 to pi. That way, it will be 1 to 1. It'll pass the horizontal line test, and then we can interchange all their variables to look at its inverse. So let's look at a couple ideas how we can find maybe some exact values of some cosine functions or inverse cosine functions. Now, finding the exact values of inverse cosine functions, very similar to finding the exact values of sine functions. Same process, the only difference is we have a different set of exact values for some of those key points along the cosine curve that we are becoming familiar with, beginning to commit to memory, beginning to see pop up a lot of the times. So let's look at an example. I want to find the exact value of the cosine inverse of -√3/2. Step one is just think about it in terms of, well, what's the angle that produces a -3/2? What's the value or the angle measurement that has a cosine of -3/2? So, well, I'm sorry, inverse right there. So let's write that then, rather than inverse, let's write that as the positive. So let's write it as the cosine of theta equals -3/2. Once I have that way, I know that my cosine of theta equals -3/2. That's my value. I can look on my value side, on my cosine theta side, and look for where is -√3/2. I know that one is connected to that particular input, that particular angle. So the angle that produces a -√3/2, boy, those are hard to say over and over again, is the angle measurement is 5/6 pi. And that's how you can find the exact value of some inverse cosine functions.